Hello everyone, I am Dr. K. Uma from the Department of Computer Science and Technology. Today we are going to discuss about K nearest neighbor algorithm. It is one of the supervised algorithm, which means we are already feeding the model with many training data. So based on the learning, based on the way it learns, it will predict the new testing data, how it predicts. So how it predicts based on with the help of their neighbors. So every time the testing data is predicted based on its neighbor's behavior. If already there are 10 apples in a basket, if a new training data is new fruit we are filling in the basket, so mostly the test data must be classified it an apple because all of its neighbors or belongs to apple category. So in this manner KNN will classify. So see, it is one of the supervised machine learning algorithm, meaning that we have trained the model with labeled data. So based on its experience it may predict the test data. So it classifies based on the neighbors. So based on the neighbors only it will classify. So how we are find out the neighbors? So who and all the neighbors? How we can find out these neighbors? So based on the distance matrix. So based on the distance function. So for each training data and testing data we have to calculate the distance. So for which data points we are getting a least value, and for the majority. For the majority we also have to check for the majority. So suppose if we are having 10 number of training data and we are supposed to have one testing data, we are having with 10 training data. Now we are give the model a new test data. So what we have to do initially, each testing data has to be compared with all the nearest training. See, all the here testing data we are having 10 training data. So all these test data has to be compared with all the 10 training data. So how can we find the distance? Using some distance metrics. We can use Euclidean distance, Manhattan distance, Minkowski distance, and any of these distance parameters we can use and find out the distance. After finding the distance, what we have to do? We have to go for majority voting. Once the distance has been calculated, we have to go for majority voting. So based on the maximum priority, we can predict the test data. Okay. So this is how the KNN algorithm works. See, suppose if we compare the features of the cat and dog, what are the features of the cat? We can tell cat have sharp claws and smaller ears. When we have compared the claws, cat has sharp claws, whereas the claws of a dog is somehow dull. And when compared the ears, we can have smaller length of ears for cat and some larger length of ears for dog. So what is this? It sounds like meows and purrs, and this is barks. It don't like to play around. It likes to turn around. It likes to walk here and there. So what are these parameters called? These parameters are called features. So these are considered to be the features. Now what is happening? Suppose we are having one new test data. Okay, see, suppose we are having one new test data. We have to find out whether this animal belongs to cat category or dog category. That is the task we have to predict. So how can we find? We have to calculate the distances. We have to calculate distance between all the nearest animals. Okay, so we have to calculate all the distance between all the animals. So based on the distance, what we can do? We have to, among the distances, we have to go for the majority voting. Majority voting we have to go for. So see, most of the features comes with cat, and there is only one feature comes in dog category. So the model will predict that the incoming testing data must be a cat because most of the majority comes under cat category. So see, we can go for any of these distance metrics. We can go for Euclidean distance, Manhattan distance, also Minkowski distance, and these are the equations we have used to solve the testing data. Okay, here what is this K? here this k is called the tuning parameter, which means we have to find how many nearest neighbors. How many neighbors we have to choose. So in this KNN, this might be a difficult task. So this k is called the tuning parameter. If we choose the k value in very small, it will be sensitive to more noisy points. So if suppose the k value is large, what will happen? More majority points from the other classes may include. That will also leads to misclassification. So always we have to choose the proper. Always we have to choose a proper k value. That is a difficult task here. So we can have the thumb rule always. So what is the thumb rule? We have to choose k is always less than the square root of n. Okay, what is n? N is the number of points. If suppose we are having 9 number of points, we have to take square root of 9, which is equal to 3. So we have to take k, the value of k equal to 3. So always, in order to avoid this confusion, we can have the thumb rule in mind. Okay. So consider this example. See, suppose this is consider this example. Okay, we are having 4 different data points, which are called what? Training points. These are the training points. And for the X data, we have to predict which class, which label it belongs to. So this is called, this data point is called what? Testing pointer. This is called what? Testing pointer. So what does this data set consist of? It consists of 4 different points with x1 and x2 are their parameters. And if x1 is 1 and x2 is 2, the data point is marked as red. If the x1 is 2 and x2 is 3, we can label the data point as red. Suppose if the data point x1 is 3 and x2 is 3, it is assuming the data point is labeled as blue. So likewise, we are having one data. So based on these data given, we have to classify whether x with x1 equal to 3 and x2 equal to 4 belongs to which label. So where do we label? Whether we can label it as red or we have to label it as blue. We have to find it out. How we can find? Based on the neighbors. So how we can go for the neighbors? We have to choose the distance between. So here we are taking Euclidean distance. So okay, so our testing point is x. We are having already the data is a. We have to compute the distance between these 2 data points. So x and a. If we take x and a data points, we have obtained the distance value as 2.83. Okay, so similarly for the next data point, we have to compute the distance between each and every data point. Suppose if we calculated a distance between the data point x and the given training point a, we obtained the distance value as 2.83. Similarly, we have to calculate for the next data point. Next data point is b and the test data is x. We have to compute distance between these 2 data points. So we are obtaining 1.41 as the distance value. So similarly, we have to do it for C and D. So similarly, like A and B, we have to proceed it for C and D. So what are the distance value we have obtained? We have obtained 2.83, 1.41, 1 and 3.16. So what we have to do? Then we have to go for the majority voting. Majority. So now we have calculated the distance for all the data points. So A is 2.83. We have to we have to go for K equal to 3. So we have to go for 3 least neighbors. So what are the 3 least neighbors? We can take these 3. So we have to go for 3 least neighbors. So we can take, compared to all the 4, we are having the least 3 as A, B and C. So these 3 data points are having least values. So how they are labeled? C, C, B, A. So these are the least distance values we have obtained. So how they are labeled? C is labeled as blue here and B is labeled as red here. Similarly, A is labeled as red. So how we can predict the final predictions? We are having 3 different cases now. Then we have to go for final predictions. How can we predict? Based on the majority voting. So out of these 3, what is the majority labeling? Out of these three, what is the majority labeling? Majority labeled is red. So the test data X belongs to red category. So this is how the KNN algorithm works. So already we are having 2 red and 1 blue. So KNN classifies the new test data as red label. Okay. So coming to the strength and weakness of KNN, how it will work. It is very simple and easy to implement. The thing is only we have to compute distance between all the data points. So it is very simple and easy to implement. It can be applied to any form of distribution. Means it can be applied to the data from any distribution, meaning that we can go for Gaussian distribution, normal distribution. So any kind of distribution, it can compare and classify and give the better results. Good classification if number of samples is large enough. If we are feeding the model with more number of training data, it will learn efficiently and will give you the good results. Suppose if we are having only 10 training data, we can get only 80% accuracy. Similarly, if suppose we are having 100 classes, we can go for 90% accuracy because already the model is trained with more number of different classes. So we can have higher accuracies. Coming to the weakness of KNN. So what are the disadvantages or weakness of KNN means? It takes more time to classify a new example. If suppose we are having 100 classes, what we have to do? We have to compare the distance for all the 100 classes. So which is a time taking task. So it will take more time to classify a new example. Choosing the value of K is very tricky. Meaning that if we are going for K value is small, it may lead to more noise. If we are taking K value is large, what will happen? If the value of K will be large, more outliers will come inside the category. So that will also lead to more noise. So always we have to follow the thumb rule for choosing the value of K. So it needs large number of samples for good accuracy. For maintaining good accuracy, it needs somehow higher number of samples. More number of samples has to be needed. Thank you.